Hi everybody, thanks for joining me. This is Parker from TestPrepChampions.com, and in this video I've prepared for you a GED Math Practice Test. I'm going to give you 23 GED Math Practice questions, and we're going to go through this practice test together. Now, if you go on the GED official website, you can pay for the GED Ready test. They give you 23 questions, and so I'm going to give you 23 questions for free. Now, I have written all these questions myself. I made these questions up. They should be very similar to the types of things that you're going to see on the real GED test. That being said, though, no one can predict with 100% certainty what's going to be on that test. So the questions you get may be very similar or they might be different. But everything on that I'm going to give you in this practice test is definitely fair game, and you should really know all of it if you want to pass. So basically, there's a couple different ways you can get involved here, and I really want you to put as much into this as possible, because the more that you put in, the more you're going to get out. So down below, you can download a free printable PDF version of this practice test. If you want, you can print it out and go through these questions if you'd like to. If not, you can just follow along with me here as we go through and just pause the video and try the questions on your own. But I really want you to try these questions as we go through here. Don't just sit there and watch, because you're going to get more out of this and you're going to remember it longer. So as we go through this, if you have any questions or if there's anything that's unclear, just let me know down below in the comment section, and I'll respond and I'll see if I can help you out to get unstuck here. And so taking a practice test is one of the best ways to improve your score. In fact, studies that have been done by the GED testing service even show that students who take practice tests have much higher pass rates and much better success rates. They score better and are more likely to pass. So we're going to get through this right now, but thank you so much for being here. Really be proud of yourself that you're taking action to pass the GED test. So let's get into it, guys, and let's get started now. Okay, first question here. We're going to answer this without using a calculator. So what's the value of the expression when x equals 2 and y equals 20? So go ahead, pause the video, try this out on your own without using a calculator. Okay, let's go over this. Hopefully you had a chance to try it. So what we want to do here is we want to pay attention to x equals 2 and y equals 20. So everywhere in the expression that we see an x, we're simply going to replace that with a 2. All right, so I see that 11x, so I'm going to want to replace that x with a 2. And the 1 plus x squared, I'm going to want to replace that x squared with a 2. And now we do the same thing with the y. So we see that y equals 20. So we want to find the y in the expression, and we're going to replace that with 20. So now we can rewrite this as 17, and we have 11x, meaning that we're going to replace that now with 11 times 2. And that's minus y. And so since we're going to replace y with 20, we just write in 20 here. Okay, and so this is minus 1 plus 2 squared now, right? 2 squared, because that x gets replaced with a 2. Okay, so we now have this lined up and rewritten, so now we're just going to use some basic math rules here to solve this out. So hopefully you've heard of PEMDAS before, the order of operations rules, but if not, or if it's been a while, that's perfectly okay. That's what you're here for, right? We're going to go over it now. So I recommend adding this to your notes if you're not too familiar with it. PEMDAS, or you can remember it by please excuse my dear Aunt Sally. And this is just giving you the order that you want to work in from left to right whenever you're doing a math problem. P is for parentheses, E is for exponents or square roots, M is multiplication, D is for division, A is for addition, S is for subtraction. And if you see an absolute value problem on your test, just treat the absolute value like the parentheses. If you don't know what I mean by absolute value, I've got another video on that on my channel. I'll put a link to that down below in the description. But anyway, you're not going to see those nearly as commonly as you will parentheses. So we're going to solve this question now, and we're going to work from left to right following these rules here. So we're going to work inside the parentheses first. All right, so let's focus on this parenthesis. And so 11 times 2 is 22. So I recommend memorizing your 11 times tables. They're very easy. But if for some reason you forget on your test, you can always do it by hand. So the way you do it by hand, just write it out on your dry erase board, scratch paper. They usually give you dry erase boards, but just write it out. It's going to be 2 times 1 is 2, then 2 times the other one is going to be 2. So that's how you would get that 11 times 2 is 22. So definitely memorize your 11 times tables. It's pretty easy. 11 times 3 is 33, 11 times 4 is 44, 11 times 5 is 55, etc., etc. So hopefully you're starting to see that pattern there. So we're going to then rewrite this as 11 times 22 minus 20, okay, minus 1 plus 2 squared in parentheses. And so now we want to do 22 minus 20. Hopefully you can see that that's 2 just by looking, but if not, here's how you would do it by hand. And don't be afraid to do it by hand on these questions where you've got, you can't use your calculator on. So 22 minus 20, we do 2 minus 0, that gives us 2. 2 minus 2 is 0. We don't even need that 0 there. We can just remember that it's 2. So now we have 17 times 2. All right, and so let's deal with what's in this other parentheses over here now. So we've got 1 plus 2 squared, and we know from our order of operations rules that we want to pay extra close attention, here to our exponent. So we want to do 2 squared, which is going to be 4. Now, how do you know that 2 squared gives you 4? Well, 2 squared, you would just do 2 times 2. Now, let's say that instead this had been 2 cubed, 2 to the 3rd power. Well, then I would just put a third 3 on here, so I'd have 2 times 2 times 2. Now, let's say instead that had been 2 to the 4th. Well, just multiply by another 2. Okay, if it was 2 to the 5th, you would just multiply by another 2, so that you would have 5 2s, 2 times 2 times 2 times 2 times 2. So hopefully you're getting the point there, but because that's going to be helpful to know for many other questions, including one coming up in this practice test. But for right now, it was 2 squared, so that's all we have to really worry about here. So we've got 2 squared is 4, so 1 plus 4 is going to be 5. So we've now got minus 5 here. Okay, so we've got 17 times 2 minus 5. So 17 times 2, again, we can work that out by hand. 17 times 2. 2 times 7 is going to give us 4. Now is going to give us 14. So we put the 4 here, put that other 1 up here. Now we would do 2 times 1, which is 2, plus the 1. So now you add that 1 on there, and you would have 34, right? So you have 2 times 7, again, is 14. 2 times 2 is 2, plus another 1 is 3. So we've got 34 minus 5. And again, as always, if you need help doing that off the top of your head, just write it out like this. So when you try to do 4 minus 5, what's important to understand here is that 4 is smaller than 5, so you can't subtract 4 minus 5 or you're going to get a negative number, which is not the point here. That's not what you want to do. So what you do is you go over here to the neighbor, to that 3. You're going to cross that 3 out and take 1 away from it. So that 3 becomes a 2. And you put that 1 on here in front of the 4. So you now have 14 minus 5, which is 9. And you just pull that 2 straight down, so you've got 29. So 17 times 2 minus 5 is going to give us 29. And we're now at our answer here, which is answer choice B. Okay, hopefully this makes sense. Let's go on to the next question. If you got this one, good job. Okay, so question 2 is another one of these questions that I want you to do without a calculator. What is the value of the expression? We see this expression here, so go ahead, pause the video, try this out on your own. Okay, so hopefully you just had a chance to try this out. So just like with the last video, we need to really double down on these PEMDAS rules. These, please excuse my dear Aunt Sally, your order of operations. So we're going to work left to right here according to these rules. So the rules tell us that we need to always start with what's inside of the parentheses. And so let's focus on this 12 minus 20 right here. Okay, so 12 minus 20, well, that's going to give you negative 8, but let's say that you didn't know that. How would you do that? Well, you just line them up like this, 12 minus 20. Okay, and so here we would do 2 minus 0, you pull that 2 down here, and now you have 1 minus 2. Well, you have to keep in mind that 1 is a smaller number than 2, and there's nowhere to borrow from here. We can't go back to that 2 and pull something out. That's not going to work. So we just do 1 minus 2. Well, that's going to give us a negative number, so that's going to be negative 1 here. So we have our negative 12, and that's very important to remember to keep that negative sign. So now when we write this, we've got negative 3 here, and we've got negative 12 inside of our parentheses. So we've got negative 3 times negative 12 plus 3 times 4 cubed. Okay, another way to say that is 3 times 4 to the 3rd power. So hopefully you know how to do this because we were just going over it. Remember what I told you in the last video. When you see any number raised to the 3rd power, you just multiply that number by itself 3 times, right? So 4 cubed is equal to 4 times, let me make that a little bit nicer, 4 times 4 times 4. All right, and so what's 4 times 4? Well, 4 times 4 is 16. So now we have 16 times 4. And so how do you do that? Well, do you know your 16 times tables off the top of your head? I sure don't. So the way I would do it and the way I'd recommend for you to do it is, as always, just write it out here. Okay, so we know that 4 times 6 is 24. So you put that 4 down here, put this 2 up here. Now 4 times 1 is going to be 4. Now add 2, so 5, 6. So we now have 64. And so now we've got this 3 times 64. So we have 3 times 64. All right, so now the next thing that we want to do is we're going to go left to right here, and we're going to work with our multiplication. So we now have -3 times -12. So first of all, a negative number times another negative number, that's always going to give us a positive number. So that's the first thing we want to keep in mind here. Now, again, as always, just do this out, just write this out by hand if you need to. So 3 times 2 is 6. And 3 times 1 is 3, so we now have 36, and that's going to be a positive 36. Remember, positive 36, because -3 times -12 gives us a positive number. All right, so we now have our 36 plus 3 times 64. So what is 3 times 64? So let's just take the 64 here, and I know my writing's a little bit all over the place, but you guys are very smart. You can follow what I'm doing. We've got 64 times 3. So what we want to do here is 3 times 4, which gives us 12. So put that 2 down here and add the 1. So put that 1 on top of the 6. Now 3 times 6 is 18. And then plus 1 gives us 19. So we have 192. And so now we do 36. And our problem is reduced to 36 plus 192. Now here's how we would do this. So let me go up here in the corner. Write this 192 plus 36. And so we'll just do the math here. So 6 plus 2 is 8. And then 3 plus 9 is going to be 12. And now we've got this 1 plus another 1 gives us 2. So the answer is 288. So let me throw this right in our box here. 288, if you got that, good job. Give yourself a pat on the back. If not, good try. Hopefully you see how to do the problem now. All right, let's go on to question 3. And from here on out, you're more than welcome to use your calculator. In fact, I encourage you to. I just wanted you to do these first 2 questions without the calculator. Okay, question 3. So calculators are fair game. And the question is, Joe must order t-shirts. A t-shirt company finds the cost C to the buyer using the following function, where S equals the number of t-shirts and N is the number of colors. C equals 1999 S plus 12 S times N minus 1. If Joe buys 3 shirts made in 2 colors, how much will the shirts cost? Write your answer in the box below. So what I want you to do is pause the video as always, try this on your own. Cool, hopefully you just had a chance to pause the video and try it out, but we're going to go over it right now. So what we need to pay attention to here is what the question is asking. So always, 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 before you try to do any work for a question, just make sure you know what it's asking so you don't waste your time. So how much will the shirts cost? So we know that cost is represented by the variable C. A variable is just another word for saying something we don't know. So we're trying to find this C, all right? And so let's look at what we're given. So if Joe buys 3 shirts, and we know up here that S is equal to the number of t-shirts. So we know that S is equal to 3 because he's buying 3 shirts. And they're made in 2 colors. So it tells us that N is equal to the number of colors, right? So, and we know that there's 3 colors. So, or I'm sorry, 2 colors. So we have N equals 2. So S equals 3 and N equals 2. So what we're going to do here is everywhere in the question where we see an S, we're going to replace that with a 3. Okay, and so everywhere in the question where we see an N, we're going to replace that with 2. Okay, so those are the arrows, so you see my thought process. Let me clear those arrows out so we have some room to work. And hopefully you see that this is really the same exact kind of question as what we did in question 1, except this is a word problem. This is a little bit different because it's a word problem, so you got to think a little bit harder for this, but hopefully not that much harder. So let's follow the same process here. So we'll do 1999, and we're going to just rewrite this, and we're going to substitute everything in here. So 1999 S. And so we already know that everywhere where we see that S, we're going to replace that with a 3. So we've got 1999 times 3 plus 12. And note how I'm leaving the dollar signs out. We don't need those. And you don't need those zeros after the decimal point. So you've got 12S, so that's going to become 12 times 3 times N minus 1. So that N we're going to replace with a 2. All right, and that's 2 minus 1. Okay, and so this is all equal to C. So now what we want to do is As always, we want to remember our order of operations rules, or please excuse my dear Aunt Sally. So following these rules here, we want to start with the parentheses. So what's in the parentheses here? Well, we've got 12 times 3 and then n minus 1. So this 2 minus 1 is what I want to start with. 2 minus 1 is simple enough, that's just 1. Okay, so we can just replace this with 1. We actually don't even need to write the 1 here, right? Because 12 times 3 times 1 is just the same as 12 times 3, because anything times 1 is anything, all right? Any number times 1 is going to be that same number. So we now have 1999 times 3 plus 12 times 3. And so let's just put this in your calculator, right? So 1999 times 3 is equal to 5997. All right, so 5997, and we're going to add that to 12 times 3. So what is 12 times 3? Go ahead, you can put that in your calculator if you want. That's 36. So now we just add this up here. So we have 36 plus 59.97, and that's equal to 95.97. So we see that the cost is going to be 95.97. So that's our answer here, but let's just make sure that that's what we originally wanted to find. So let's ask ourselves, does this answer make sense? So if Joe's buying 3 t-shirts for about 20 bucks in 2 different colors, then how much will the shirts cost? And this is our formula up here where, again, n is equal to 2, so 2 minus 1 is just 1. So we're basically doing, let's round that to 20, so we're essentially doing 20 times 3 plus 2 times 12. Yeah, that seems like that would be about 95.97. So this is going to be a safe bet. So that's the answer. And I just want you to get in the habit of doing that extra little step to just ask yourself if your answer makes sense before you leave it as your final answer on the test. All right, guys, next question. Let's move on here. Let's keep it rolling. Okay, question 4. A ladder is leaning up against a shed. The ladder touches the shed wall 14 feet above the ground and touches the ground 10 feet from the base of the shed wall. What's the length of the ladder? So go ahead and pause the video, try this out on your own. Okay, so hopefully you got a chance to try this. And so what I want you to see here is that we see our shed wall and we see the ground and we see a ladder. But what this really is this is essentially just a triangle problem, right? So the shed wall and the ground and the ladder just make up this triangle here. So that's the point of the question. So the first part of getting this right is to recognize that. The second part of the question, though, is to understand the Pythagorean theorem. And it might sound like I'm speaking Greek, and well, that's because I am. Pythagoras was a ancient Greek philosopher. So anyway, that's not important for your test. But the Pythagorean theorem is basically this equation right here, where we see that a squared plus b squared equals c squared. Okay, and so if you look at the triangle here, we see a squared plus, we see here's our a, here's our b, and so if we take a squared and we add that to b squared, the answer is going to be c squared. Now, sometimes people might write it this way. They might write it so that instead of this might be a b, this might be an a. It doesn't really matter. It's not really that important. You just have to, it doesn't matter how you write it, you just have to know that one side is side A, one side is side B, but C is the important side because that's the hypotenuse. So what is the hypotenuse? Well, this is a right triangle, and so the Pythagorean theorem is going to apply to a right triangle here, and you can recognize a right triangle because it's got a 90-degree angle here. So you see this one side of the triangle, it goes straight down. It doesn't look like it's going straight down because of my writing, but just imagine that's a straight line going down and that this is a straight line going this way. And so these two lines are perpendicular, right? These two sides of the triangle, they intersect each other and they form a 90-degree angle. So perpendicular lines intersect to form a 90-degree angle. And that's what we see here. This little box type thing, this little box type looking thing in the corner here, that just tells us that we have a 90-degree angle. All right. And the side of the triangle that's opposite of the 90-degree angle is the hypotenuse, which is the largest side of the triangle. So you might be wondering, what does all this matter? This just sounds a little bit, this is a little bit hard to follow. Well, don't worry, because you don't really have to know any of that. Just remember that the biggest side of the triangle is called your hypotenuse, and that's side C. And the other two sides, here's side A and here's side B. And so all we want to do here is we want to find side C, because side C represents the ladder. So we know that this side, 14, let's let that be equal to A. and 10, we're going to let that be equal to b. So now we're going to use this formula up here, the Pythagorean theorem, a squared plus b squared equals c squared. And so we're going to plug these numbers in here or substitute them in. So 14, that's equal to a. So we're going to replace a with 14. So we've got 14 squared plus 10 squared. All right, plus 10 squared, and that's equal to c squared. Now, you can just put this in your calculator. So in your calculator, do 14 squared, okay, or 14 times 14, however you want to think about it. That's going to be 196, plus 10 squared, 10 times 10, which is 100, okay, and that's equal to c squared. So now we want to do 196 plus 100. Again, you can put that in your calculator, or you can just see that it's 296, or you can do it by hand, but I certainly wouldn't recommend ever doing a question by hand if you can use your calculator, unless you're just writing out some of the steps to show your thought process along the way to help yourself. But anyway, we see that 296 is equal to c squared. So is the answer 296? No, it's actually not, right? Because we're trying to find the length of side C, or the length of the ladder, and we just found the length of the ladder squared, okay, or side C squared. So we need to take the square root. So you need to take the square root of 296. Okay, so take the square root of 296, which is going to give you, I think, a weird number here. 296, square root of that. Yeah, that's going to give you about 17.2. It's a little bit of a weird number, but that is going to be our answer here. All right, so that's how you would do this question, and so hopefully this makes sense. But this is important. These questions do pop up on the GED test fairly commonly, so you definitely want to know how to do this question. And so that's good, guys. Let's keep moving here with the next question, question 5. Okay, question 5. What's the value of 3 to the 9th power? Go ahead, pause the video, try this out on your own. So hopefully you just got a chance to try this out on your own, and hopefully you've been paying attention here and you've already remembered me explaining how to do these questions. Remember I said earlier on that understanding how to do exponents would be important for a later question. Well, this is that later question. So 3 to the 9th power. Well, what you want to do is you want to write, I would write this out by hand and then do it in your calculator. So you want to do 3 times 3 and then times another 3 times another 3, and you want to keep doing this until you get 9 3s. So we've got, let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 3. Okay, so when I said 8, I meant that was the 8th 3. So let me count these up. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, great. So you just do this in your calculator. I'm going to do it right now. 3 times 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 3. And that's going to give me 19,683. So hopefully you got that question. Just be careful that you really pay attention to how many 3s you put into your calculator. I guess you don't necessarily have to write this out by hand first. You can just put it in your calculator, but I wanted to write that out here so that you guys understand the concept of how to do this question. So hopefully you got this. Let's go on to question number 6. Along now with question 6. What is the surface area of the cylinder? And on the screen here, I've given you the formula for the area of the cylinder. So you're not going to have to memorize this formula for your test, but you should know how to use it. So as always, pause the video, give this a try. Okay, hopefully you just tried this out. Like I said, you won't have to memorize this formula, but you're going to have to know how to use it. And you're going to have to be able to go through your formula sheet and figure out which formulas you need to use. So this is the formula for the area of the circle. So you have to know what R is and you have to know what H is. So R just stands for radius. So I've made other videos about how to understand the difference between the radius and the diameter in a circle. So you'll want to check those out if you're having a lot of trouble with this. But let me just give you a very quick lesson. Let me pull up a circle here. And this is very important to know because circles will come up on the GED test depending on which version of the test you get. So here we see a circle. And so if you see a line that measures from one edge of the circle to the center of the circle, this is measuring the circle's radius. However, if the line extends the whole way across the circle from one endpoint to another endpoint, we would say that this whole thing here is measuring the diameter. Okay, D for diameter. And it might be lowercase or capital D depending on how they write it, but it's the same thing. So we can say that the radius is equal to half of the diameter, or D divided by 2. and we can also say that the diameter is equal to twice. This pen is really acting up right now. The diameter is equal to twice the radius. Okay, so file this away in the back of your head because you might need to know this for your version of the test. And like I said, I've got other videos on circles, but that was just an aside here that you want to keep in mind here. So the point here is that this top part of the cylinder is a circular portion, right? And so the 3 is going to be our radius. So 3 equals our radius. And then the other part that just goes up and down is the height here. So 6 is going to be our height. So 6 equals h. And they'll usually tell you what a shape is, but if you want to remember a cylinder, just think of cylinder soda, because it looks like a soda can, doesn't it? Kind of from the side angle or from the front. So cylinder soda can, just file that away in your memory as well. And so now, as always, what we're going to do is we're going to plug the 3 in everywhere we see an r into the equation, and we're going to do the same now with h. We're going to plug 6 in for h. And so if you do this, you'll have 2 pi. And by the way, pi is just a number. It's 3.14 and then a bunch of other numbers that go on and on and on and on. You don't really have to know that. Just know that pi is equal to 3.14. But usually you're just going to want to leave pi as the symbol pi. You don't always have to deal with the number 3.14, but just know that pi is approximately equal to 3.14. So that's definitely something you want to put in your notes just in case it comes up. So we've got 2 pi times r squared, which is going to be 3 squared, plus 2 pi rh. So we put in here for our r, we put 3, because remember, we're substituting 3 in for r. And for h, we're going to plug 6 in here, because remember, we're substituting 6 in for the h. So now we're just going to work left to right, and we're going to remember, as always, our PEMDAS rules here. Let me pull these up here. Just put them on the screen here, because we always need this repetition to drive this home. So for really almost every math question, I'm just going to lay this on top here. For PEMDAS, you're going to want to run through these rules mentally in your head. And again, we've got parentheses, exponents, and square roots, multiplication, division, addition, and subtraction. All right, so let me slide this back off here to give us some room to work. But, hopefully you're getting tired of seeing that PEMDAS by now, and that's good because that hopefully means it's going to stick. So we want to start with our exponent here, right? So we want to start with 3 squared. So 3 squared is just 3 times 3, so we can replace that with the 9. So we've got 2 pi times 9. And I'm working this out step by step here, and you don't necessarily have to rewrite the problem every single time like I am doing here. I'm just doing this to demonstrate, although it's certainly not a bad idea as long as you are mindful of the time on your actual test. So now we want to work left to right, and we're going to use multiplication first, then we'll do that addition second. So we've got here 2 pi, 2 times pi times 9. So let's just do 2 times 9, which is going to be 18. And we're just going to leave pi alone. We're not going to mess with it. And so now over here we've got 2 pi 3 times 6. And so again, let's leave this pi by itself here. Let's not mess with it. So we've got 2 times 3, which is 6. And then 6 times 6 is 36. And don't forget that we've got this pi here. All right, so now would be a good time to put this in your calculator if you would like to. We're doing 18 plus 36, which is going to give us 54 pi. And I always recommend using your calculator for the questions that you're allowed to use your calculator on, even if you don't think you need to, because as long as you put the answers into your calculator correctly, you're going to get the correct answer 100% of the time. So the answer here is going to be A, 54 pi. So hopefully this was pretty easy. This is just what they call a plug and chug problem, where really you're just going to identify the radius and the height, and then you have to know this formula, which will be given to you, but you've got to know how to find it from the formula sheet, and then you're just going to substitute the numbers in where we see an R, you put in 3, and where you see a 6, you use H, and then as always, you want to use your PEMDAS rules. Please excuse my dear Aunt Sally, parentheses, exponent, square roots, multiplication, division, addition, subtraction, and you want to use these operations going from left to right, and that's what we did here with our exponent. Then we did our multiplication, then lastly our addition, we got 54 pi. So hopefully this is pretty straightforward. Let's move on to the next question. Question number 7. Jen spends 2 hours pedaling her bike from her house to her cousin's house. It only takes her an hour and a half to bike home. If Jen's cousin lives 10 miles away from Jen, what was her average rate of speed in miles per hour rounded to the nearest whole number? And so let me give you the formula you'll need here. It's the distance formula, where distance equals rate times time. Distance equals rate times time. So again, go ahead, you know the drill, pause the video and give this one a go. Okay, so now let's go over how to do this question here. So we have to know how to use this distance formula here, but I want to draw a picture here to help us break this down conceptually. So let me just make a stick figure here. Let's say that this is Jen, okay, and let's give her some hair here, add a little bit of life into the stick figure, and let's give her a big smile because she's going to ride her bike to go see her cousin. So this is Jen, and let's say that this is at Jen's house, okay, and so now let's say, okay, so she rides her bike here, so this is the path. And let me draw, say that this is her cousin's house here. Okay, so maybe she's got, some big old windows here, and some big old windows, and big old door right in front of the house. There's your doorknob and a chimney. And let's say, let's give her some smoke popping out of the chimney here, just for fun. So before we really try to solve the question, though, I hope that you zoomed in here on this part of the question, the most important part. So what I always coach people, this is kind of a pro tip here, make sure that before you solve a word question, I would even underline or just really zoom in on what you're being asked before you even try to solve it. So what was Jen's average rate of speed in miles per hour? So that's what we're trying to find here, right? So at the end of the question, once we get an answer, we want to make sure that we've actually answered this part of the question. So don't try to just do a bunch of calculations and figure it out before you've really clarified what you're actually trying to do. It should be common sense, and it is common sense, but a lot of students skip it and they have trouble because of it. So here's Jen. She starts out at her house, and so she bikes to her cousin's house. And so we know here that, let's say that we know that she lives 10 miles away. So this distance here is going to be 10 miles. Okay, and so, man, this pen is really giving me a hard time here. So that's 10 miles. And so what we want to do is we want to find the terms for this equation here, because what we're trying to find is a rate, because it says what was the average rate of speed in miles per hour. So we don't know what R is. So let me put a question mark here for R. And so we're going to have to use D, and we're going to have to use T. Okay, and we're going to plug those numbers in, and we're going to find R here. So we know that the distance from her house to her cousin's house was 10 miles. All right, and so it says that it takes her an hour and a half, it takes her 2 hours to get there. So the ride there is 2 hours. Okay, so she gets there and they have tea or do whatever they're going to do, have a grand old time. And then Jen is going to go back now. So here's Jen, and she rides back to her house now. And so again, we know that this distance is still 10 miles. Okay, and so it tells her, it says that it took her an hour and a half to bike home. So it took her 1.5 hours to bike back home. So maybe she had a Red Bull or an energy drink or whatever, but for whatever reason, she rode back a lot faster. So now when we add up our distance and our time here, we've got to factor in everything. So we would do 10 plus 10 here, right? Because we're looking for the average rate of speed during the whole entire trip, right? Okay, so we've got this 10 plus 10. And then we also have to factor in the time. So we want to do 2 plus 1.5, which is going to give us 3.5, right? So we've got to factor in everything here. Okay, so if her cousin lives 10 miles away from Jen, what was her average rate of speed in miles per hour? And the question is asking us for the whole entire trip, not just from her house to the house or from her house back home. So that's why we have to get everything in here. So our distance is going to be equal to 20, and our time is going to be 3.5. Okay, so now what we're going to do is we're going to take this question here, and we want to solve this equation for our rate, because that's what we're trying to find. So we see over here that R is multiplied by T. So what we do is, to get rid of that T, we got to divide by T on both sides of the equation, because whatever you do to one side, you have to do to the other. So T divided by T is 1. We're then left with D divided by T equals R. So now we're just going to plug this in here. So our distance is 20. And our time is 3.5. So now let's put this in our calculator to see what we get. So we do 20 divided by 3.5. That's going to give us 5.7. Okay, and so to round that up to the nearest whole number, we look at the 7 here and we say, well, 7, that's going to round us up to 6 here. So that rounds up to 6. So if this 7 here had been a number less than 5, like 4, 3, 2, or 1, we would round this down. We would have rounded this down to 5, and A would have been the correct answer. But if this had been a 5 or a number bigger than 5, which it happens to be 7, that means we round up, so C is going to be our answer here. All right, hopefully that's clear, and hopefully that makes sense. All right, let's keep it rolling here. Question number 8 is about simple interest. Sam loaned $650 to his sister for 6 months, who agreed to pay him simple interest at an annual rate of 7%, including both interest and the principal. How much will Sam's sister have paid him after 6 months? So whenever you see the words simple interest in a question, hopefully that's going to cue you into this formula here, which is I equals PRT, which again, this will be given to you on your test. I equals interest, P equals principal, R equals rate, and T equals time. So go ahead, pause the video, and try this out on your own. This is the formula you'll need. Okay, hopefully you had a chance to try this out. So well, the first thing that you do whenever you see a word problem is to pay close attention to what you're trying to find. So before you do any calculations, before you even think about how to solve the problem, just double check what you're trying to find. Because there's a lot of numbers and a lot of different factors in these word problems, but I want you to first pay attention to this. So what we're really trying to find here is how much will Sam's sister have paid him after 6 months. So if we get an answer and the answer doesn't satisfactorily answer the question here, then we know that we're way off, all right? So now let's look at the terms that we're given here. So Sam loaned $650 to his sister for 6 months. So the initial amount, or the amount that you're investing, is the principal here. Okay, so let's say that P is equal to 650. Okay, P equals 650. And so then the time is going to be, it says 6 months, let's come back to that, who agreed to pay him simple interest at an annual rate of 7%. Okay, so we're talking here about an annual rate, and almost every simple interest question that you're going to get is going to be dealing with annual rates. Okay, so what we're going to have to do here is for our time, you have to put the time into years, not months. So 6 months is going to be half of a year. Okay, so we can just say that time equals 1/2, right? Now, if for some reason like they give you something weird like 9 months, hopefully you'd be able to convert that into years. But if you couldn't, here's what you would do. So you would just say that, for example, you're given 9 months here. How would you put this in terms of years? Well, you would say here's 9 months. Okay, so you'd start by just writing down 9 months. And so how many months are in a year? So well, we know that there's 12 months, okay, in 1 year. So now we would just do a division problem here. And so you could use your calculator, and you'd probably want to leave this as a fraction. I wouldn't do it as a decimal, but you've got 9 months, and so you can do, what can we do here? Let's divide a 3 out of both of these terms. So 9 divided by 3 is 3, okay? And a 12 divided by 3 is going to be 4. So the months are going to cancel out here. And so we'd essentially be left with 3 over 4 years, okay? So if it was, for example, if they had given you 10 months instead of 9 months, right? Like let's say that this had been a 10, you would do the same thing. You've got 10 months times 1 year over 12 months. So again, the months are going to cancel out here. And then you would say, well, how can I simplify this? Well, if we can take a 2 out of the 10, and we can also divide 12 by 2. So 10 divided by 2 is 5, and 12 divided by 2 is 6. So you would have 5/6 of a year. Okay, so hopefully this makes sense here, but you shouldn't have to deal with this. But if you do on the test, you'll be prepared. But the main point here is to understand that for 6 months, we're going to put that into years. So 6 months is half a year. So our time is going to be T equals half. Okay, so now we have to deal with this rate here. So we've got a rate of 7%. And so 7%, we want to express that as a decimal. So 7% is equal to 0.07. Now, if it had been 70%, hypothetically, we would do R equals 0.7. So 0.7 is equal to 70%. 0.07 is equal to 7%. So since we have an annual rate of 7%, we use R equals 0.07. So now, as always, we're just going to plug this in. And so we would say I equals P, which is 650, times R, which is 0.07. Okay, and then lastly, we're going to multiply by half. All right, so in your calculator, you would just do 650 times 0.07, okay, and then divide by 2, and that's going to give us 22.75, so answer A is the correct answer. Okay, so number 9, Jason played in 8 basketball games, and his scores were 20, 38, 16, 4, 10, 32, and 20 points during each game, respectively. So what was Jason's average number of points scored in these 8 games rounded to the nearest whole number? So you know the drill. Try this on your own, and then we'll go over it. Okay, so let's underline what we're trying to find here. So what was Jason's average number of points scored in these 8 games? So we're looking for the average number of points, and this keyword here is average. So the strategy we're going to use is finding the average, and another word for average is mean. So let me pull some notes up here on the screen. And so you might get a question that's asking you to find the mean, median, and mode of a data set, or just the mean. And so in this case, the word mean and average, they are the same. Mean means the average, pun intended there. Okay, so the words average and mean are the same thing. And the same process you use to find the average is the same exact process you use to find the mean. So all you do is you add up all the numbers in the data set and divide them by the total number of numbers. So what I mean by that is you're going to take all these numbers in your data set, your 20, 30, 8, 16, 4, 10, 32, and 20, add those all up and divide by the total number of numbers in the data set. So what do I mean by that? Well, you can just count them up here. You see we got 1, 2, 3, 4, 5, 6, 7, 8 numbers. And it also tells us in the question that there's 8 different games. So you're going to add all these numbers up and divide by the total number of numbers. Okay, let me pull these notes off the screen here. Let me see if this is going to work. Let's see here. Let me pull this up here. Yes, it did. Beautiful. Okay. And so this is the work that you're going to use to solve the problem. Let me put this around parentheses, and this is an 8 down here. The 8 might be cut off just a little bit, but I wrote this out before the problem because I wanted to save us some time here. But this is what you're going to do. You're going to do 20 plus 30 plus 8 plus 16 plus 4 plus 10 plus 3. So you're going to add this all up, and then you're going to divide that by 8. And so let me put that in the calculator. We got 20 plus 30 plus 8 plus 16 plus 4 plus 10 plus 3, which gives us 91. Let me just make sure I did that right. We got 20 plus 30 plus 8 plus 16 plus 4 plus 10 plus 32 plus 20 gives us 140. So actually some of the numbers got cut off here. Plus 140. So, okay, here's the problem here. So this should be 10 plus 32. This parenthesis should not be here. So just ignore this parenthesis. And so we've got 32 plus, what is that at 33? Okay, we've got 32 plus 20. And so if we add these all up, 20, 30, 8, 16, 4, 10, 32, and 20, we get 140. And lastly, we're going to divide that by 8. And that's going to give us 17.5. So this is all equal to 17.5. And so we know that that rounds up to 18. So the answer is going to be C, 18. And hopefully this makes sense. So again, this number here, the fact that this is a 5, that's very important because that tells us that we're going to round this up to an 18. And that's why choice C is the correct answer. So hopefully this makes sense. Again, whenever you need to find the mean, just add up all the numbers in the data set, and then you divide by the total number of numbers in the data set, which is what we did here. And like I said, I wrote this out beforehand to try to save us some time, but it clipped off my 32 and my 20, so it ended up costing us a little bit more time, but that's okay. Hopefully this illustrates the concept and the point behind trying to find the mean. So let's now move on to question 10. Okay, question 10 is, what is the median number in the data set 29, 3, 50, and 9? So what we just did was we were finding the mean or the average. So now we're going to find the median here. And so go ahead, you know the drill, give this the old college try, pause the video. Okay, hopefully you had a chance to try this out now. So I'm going to write out a note here because this is an important nuance here. So the median equals the middle number in the data set when, and this is an important nuance, when the numbers are ordered from smallest to largest. Okay, and I'm going to put a triple exclamation points here because this is very, 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 very important that you do this whenever you get a median question. So I'll underline this because this is really, 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 really important. Okay, a lot of people remember the first part, that the median is the middle number, and that's very good. I mean, that's good. A lot of people remember from high school or whenever they learned this before. They come back and study for the GED a couple years after they've been out of high school, or sometimes even 10 or 20 years after high school, and for whatever reason they remember that the median is the middle number. And that is correct, except it's the middle number when the numbers are ordered from smallest to largest. So you have to remember to order the numbers from smallest to largest first. But technically, yes, that is correct. The median is the middle number in the data set, but it's when the numbers are ordered from smallest to largest. So if you don't do that, if you just look at the numbers and you just go right to the middle number, then that's probably not going to be correct because you've got to order them first, right? And so that's the first thing that sometimes trips people up with median questions. So if you just remember this point here, that median is the middle number when the numbers are ordered from smallest to largest. And yes, I am really hyping this up because you got to remember that. The median is the middle number when the numbers are ordered from smallest to largest. So you got to remember that. So first thing that we're going to do here is we're going to order these from largest to smallest. And there's one other nuanced point here that we must go over. So to order these from smallest to largest, we just think about counting, right? So if you were going to count 1 through 50, you would say, well, 3 and then 9 and then 29, right? So we would say 3 and then 9 and then 29. So hopefully just ordering whole numbers like this is pretty straightforward for you. You just want to think about counting or even think about money, right? Like, which would you rather have, $50 or $3? I think obviously we know $50 is more money. Okay, so therefore 3 is a smaller number. So there's two ways to think about it when you're ordering numbers. Just think about it as counting or think about it like money. But either way, this is how we would line these up from smallest to largest. So 3, 9, 29, 50. So now here's the other nuanced point, right? So you'll hopefully notice that there is no middle number here. So we've got an even number of numbers in the data set, so there is no middle number here. So what you're going to have to do is you're going to have to take the average of the two numbers in the middle. Now, let me show you a case where you wouldn't have to do that. So this is what people are more used to doing. And so they get they get tripped up when this isn't the case, when things don't work out this nicely, which oftentimes GED test writers, they don't want the problems to work out nicely for you, right? Or I guess they do want you to succeed, but still they're going to try to throw some trick questions in there at you, and you want to get it done with the math test. You don't want to, go in there and BS around, so you want to get it all done on your first try. So here we've got an odd number. We've got 1, 2, 3, 4, 5. So here we have a clear middle number. So 6, and these numbers are not ordered. Yeah, they are ordered from smallest to largest. So our middle number is 6 here because we've got 1, 2 numbers here. So if you approach it from the left-hand side, right, you see we've got 2 numbers, 1, 2. Then if you approach it from the right-hand side, you see we've got 2 numbers here, and 6 is right in the middle. Okay, so usually you'd be able to just look at the middle number here, but when there's an even number of numbers in the data set, you cannot do it this way. You've got to take the average here of these two numbers. So if you just write 9 in here, if you write 29 in here, both of those are going to be wrong. What you have to do is take the average. And so hopefully you remember how to take the average, because we were just looking at a problem like that a few minutes ago, but let me get my notes up here. So add this median to your notes here. Median is the middle number when the numbers are ordered from smallest to largest. So hopefully you put that in your notes if you want to. And now we're going to look at notes on the mean real quick, just as a refresher. So the mean, to find the mean or the average, you just add up all the numbers in the data set and then divide by the total number of numbers. So in this case, we're just trying to take the mean, or we're just trying to find the average between two numbers here, between 9 and 29. So really, we're not going to look at all of these numbers in the whole data set. Our data set is just these two numbers because we're trying to take the average of 9 and 29. So what we do is we're going to add these up, 9 plus 29, and divide that by 2. And that's going to give us our answer. And let's see here. Okay, so I didn't have you round this to any certain number, so we might get a weird decimal here. Let me just see how this works out. Okay, so 9 plus 29 is 38. Divide that by 2. Oh, no, it doesn't. That gives us 19. Okay, perfect. That works out very nicely. So what we do here is 9 plus 29. That's going to give us that's going to give us 38. And then you just divide 38 by 2. And again, just throw this in your calculator for the sake of speed, and you end up with 19, which is the correct answer here. So whenever you're trying to do one of these median questions, again, always remember to order the numbers from smallest to largest, and then just look and see if there's a middle number, right? If there's an odd number of numbers in the data set, then you just look at the middle number and then you're done. As was the case in this little mini example up here that I'm putting a box around, right? We could just pick 6, but in the real example here, we've got an even number, so there is no middle number. So you've got to look at the two middle numbers, add them up, and divide by 2. So for a median question where you've got an even number, just always add up the two numbers that are in the center of the data set and divide by 2, and you're going to get the right answer, okay? So hopefully, you might remember these PEMDAS rules, and you might remember that you're supposed to always do the addition. You're supposed to always do division before you would do addition normally, right? According to the PEMDAS rule. So why did I do 9 plus 29 and then divide it by 2? Well, the reason is because really you can think about there being an imaginary set of parentheses up here, right? You can't do 9 divided by 2 and then 29 divided by 2, right? That's not how this, well, I guess you could, but you would get weird numbers, right? So really, we could split this up as 9 divided by 2, okay, 9 over 2 plus 29 over 2 as a fraction, okay? And then when you would go to add this up, you would just do 9 plus 29, and that gives you 38. And you keep the numerator, or I'm sorry, the denominator, which is the lower number in the fraction, the same. Okay, so hopefully that makes sense here. But the point is that you've got to add this 9 and this 29 first. So just imagine, like on the top number here in the fraction, that there's like a set of parentheses around it here. Okay, or you can break it up, and when you see 9 plus 29 divided by a number down here, you can break it up as, and think about it as 9 over 2 plus 29 over 2. That might be even more confusing. So if this is even more confusing for you, don't worry about it. But just remember that, you know, you've got to add these numbers up first, and it's going to be easier to solve the question. So if these were all even numbers, like say for example this was like 10 plus 30 divided by 2, okay, then you could divide a 2 out of every single number in the set. So you could do 10 divided by 2, which is going to be 5, and then you would do 30 divided by 2, which is going to give you 15, okay, and then 2 divided by 2 is just 1, so you're left with 5 plus 15 over 1, which is going to be 20, okay. So you can do it that way, and let me show you how if you split it up, it's really the same thing, right? So if you split this up into 10 over 2, okay, plus 30 over 2, and then you simplify both of these fractions. So then you would simplify, you would do 10 divided by 2, which is going to give you your 5, 30 divided by 2, which is 15, and either way you end up with 20. Now hopefully I'm not confusing you here more, but I just like to explain things for people who want to understand on a deeper conceptual level what is really going on here in the mathematics. But anyway, so that's why you would want to do that. So just the point here is that if you ever have a situation like this where you've got like a bunch of numbers and you're adding them up in the numerator and you've got one number down here in the denominator is the lower number in the fraction, the numerator is everything in the top part of the fraction. Okay, you want to always add those numbers up first and then divide. The only exception would be if you can divide the number in the bottom number, like if you can simplify first. Like if these had been even numbers like I showed you, it would be easier to divide 2 out of both of these. But you know, you could just do 9 divided by 2 in your calculator, get a weird decimal, and then do 29 divided by 2, get a weird decimal, and you could add it up that way. And let me show you what would happen if you do that. So like you would do 9 divided by 2, that would give you 4.5, and then you could add that to 29, and then you do 29, divide that by 2, which would give you 14.5, and then if you add that up, that's going to give you 19. I don't really know why you'd want to think about it that way, but that is certainly a valid way to do it if that works for you. But anyway, the bottom line here is that you want to really zoom in on these two numbers here in the middle of the set, add those up and divide by 2, and that's going to give you your answer here. So sorry if I confused you a little bit more, but I like to explain things in depth, and just by listening to you know, the math, you're going to learn it. And so let's move on now to question number 11. Okay, question number 12. Mrs. Thomas wants to take her husband and her 2 children to the movies. Both children are under 13. How each child will bring 1 friend of the same age along. The ticket prices are as follows in the table below. Hopefully you can read that on the screen there, but I'll read it anyway. Adults and teens 13 years old and up, it's $10 for a day show, $12 each for a night show. For children under 13 years old, $7 each for a day show and $9 each for a night show. If Mrs. Thompson is buying the tickets, how much money will she save on the cost of the tickets if they attend a day show instead of a night show? Disregard sales tax in your answer. So go ahead and you can try this out on your own right now. Okay, hopefully you had a chance to try this on your own, so let's go over it. So this is another one of those questions. It's a perfect example of why we want to kind of just sit back and let's think strategically here before we jump right into solving it. So as always, what are we really trying to find here? Well, we want to find the amount of money that she's going to save on the cost of the tickets if they attend a day show versus a night show. So that's what we're looking at. We're looking at the amount of money she'll save if everybody attends a day show and a night show. So first of all, the day show versus the night show. So basically, let's map this out here. So we want to think about how many people that she's bringing here. So let me split this up here. This would be the calculation for our day show. Okay, so we're going to do that right here. And here's where we'll do the calculation for our night show. So, but before we do that, let's figure out how many people are coming here. So we've got Mrs. Thompson wants to take her husband and her 2 children to the movies. Both children are under 13, each child is going to bring one friend along of the same age. So how many adults do we have here? So the adults here are going to be 2, right? Because we've got Mrs. Thomas and her husband. So let's put adults. Let me make a note that we've got 2 adults here. Okay, and then how many children do we have here? Well, we've got their 2 children, and then they're each bringing one friend of the same age a lot. So let me just put here children, or you know what, let me make it even simpler. Let's just call them kids. And so there's going to be 4 kids total here, right? Because of Mrs. Thompson's 2 children, and each of them are bringing a friend along, so we would have 4 kids here. So we've got 2 adults and 4 kids. So let's find the cost of a day show. So it's telling us here in the chart that it's for adults and teens 13 and up, it's $10 each for a day show. So we've got 2 adults. So we've got 2 adults, and the cost is going to be $10 each. So let me put 10 here. So we would do 2 times 10, and that's going to give us the cost for the adults. And then now we're going to add that to the cost for the kids. So the price here for a day show for children, it's going to be $7 each, and we've got 4 kids. Okay, so we've got 4 kids, so we're going to do 4 multiplied by 7. So 4 kids, and each children's ticket is going to be $7 each. So we're just going to now do this in our calculator here. So we would do 2 times 10, which is 20, and 4 times 7, which is 28. So we have 20 plus 28, and this is going to equal 48. And let me circle this because this is what we're going to have to come back to. So the total amount for a day show is $48. And so answer B is not correct though, because remember, we're supposed to be finding how much she's going to save on the cost of tickets if they go to a day show versus a night show. We're not just calculating the cost of a day show. So that's why it's so important to first figure out what you're trying to solve here. So now let's do the same thing for night show. So again, let's say that there's 2 adults, right? And the cost for each adult is going to be 12. So we would do 2 times 12. That's going to give us the cost for the adults. And we're going to add this to the cost for the kids. So there are 4 kids again. And for each kid, it's going to cost $9. So we would do 4 times 9. And okay, let's now throw this in our calculators here. So we've got 2 times 12, that's going to be 24. So we have 24. And this pen is really driving me nuts here. So 4 times 9 is 36. And 36 plus 24 is going to be 60. All right. So is answer choice C the correct answer? Is the answer 60? No, the answer is not 60, because remember, the question is not asking us to find the amount of money that they're going to have to pay to go to a night show. We want to find the difference between the night and the day show. So to get the answer, we're going to subtract. So we would do 60 minus 48. All right, and so let's just put this in our calculator here. 60 minus 48, and that's going to be 12. So the cost is going to be $12. All right, and so let's ask, does this make sense? How much money are they going to save on the cost of day shows versus night show? Well, $12, that sounds about right. All right, so hopefully you got this question. Hopefully you see the importance of really zeroing in on what you have to find before you try to jump in and solve the question. Because if you would have just calculated the amount per day and you would have thought, wow, I calculated that correctly, 48, yay, that's my answer B. No, it's not your answer. That would have been wrong. And the same with 60. So if you got the calculation right for the cost for the night show, but you found 60 over here and you picked 60, okay, that would have been incorrect. And also, if you had tried to add them up for some reason, if you would have tried to do 60 plus 48, that was wrong as well. You needed to get the distance, not the distance, the difference between 60 and 48. You do that, you subtract 60 minus 48. That's going to tell you how much she saved by going to a day show versus a night show. All right, so definitely make sure you understand this question, because these types of word problems are very common on the test. All right, so let's move on now to lucky number 13. Okay, question 13 is all about probabilities. So I put the formula here for probabilities. Probability of an outcome equals the number of favorable outcomes divided by the total number of outcomes. So go ahead here, try to solve this question, pause the video, you know the drill. All right, let's try to go over this. So a jar has 14 red, 8 orange, 12 green, and 16 pink marbles. What is the probability of drawing a pink marble if a single marble is drawn at random, expressed as a percent? So let me make sure that we're clear on what we're trying to do here. We want to find the probability of drawing a pink marble if a single marble is drawn at random. And we're going to express it as a percent. Okay, so probability is just, when you're asked to find the probability, you're just trying to figure out how likely something is to occur. So we're basically trying to figure out how likely is it that we're going to draw a single pink marble here. So the probability, so the outcome in this case is drawing a pink marble. So the probability of drawing a pink marble is equal to the number of favorable outcomes, which would be the number of pink marbles that we have in the jar, which is 16. Okay, and we're going to divide that by the total number of outcomes. So we're going to add all these numbers up here. So we're going to do 14 plus 8 plus 12 plus 16. I'm going to do this in my calculator. You can do it too. 14 plus 8 plus 12 plus 16. So we add these all up, and that's going to give us 50. All right, so we do 16 divided by 50. 16 divided by 50, and I did that in my calculator, and I got 0.32. So now 0.32 expressed as a percent is just 32%. All right, so answer choice D is the correct answer here. Okay, question 14. What's the missing angle of the trapezoid? Go ahead and try this on your own. Okay, let's go over it. So what you have to know here is that when we're talking about a trapezoid is a type of a four-sided plane figure. Okay, it is a four-sided plane figure. And four-sided plane figures are very important to understand. So first of all, you'll recognize them because they have, well, four sides. There's four closed sides, four-sided plane figures. And some of the most common ones are obviously the trapezoid, which you see on the screen here, but we also have the rhombus and the parallelogram, squares, and rectangles. So these are all different types of four-sided plane figures. And I've got a video on my channel. You'll want to go under my GED Math Lessons playlist, which I'll link to at the end of the video, and I'll link to this down below if I remember to. But you'll also want to check out my video on four-sided plane figures. I go very in-depth, so if you want to know more about how to handle those problems with the squares, rectangles, parallelograms, trapezoids, rhombus, you can see that all in there. But basically, the idea here is that with all four-sided figures, all of the internal angles are going to add up to 360 degrees. So again, all of these internal angles will add up to 360 degrees. So let me make a note here of that. So this should go in your notes. So all internal angles in a four-sided plane figure will add up to 360 degrees. Okay. So knowing that, we can now solve this question fairly easily because we can just make a basic algebraic equation. So we know that all of these internal angles are going to add up to 360. So we can make an equation. 360 is equal to 72 plus 75 plus 105 and plus x. And I'm writing an x here for this angle right here. So this angle that we don't know what it is here with the question mark, I'm just going to call that x. So that's essentially what we want to find here. So to do this, we're just going to do a simple addition. So we want to add up 72, 75, and 105. So I'm going to do that in my calculator. So 72 plus 75 plus 105, and that gives us 252. So let me rewrite this now. So we've got 360 equals 252 plus x. Okay, so now we want to solve the equation for the variable. X here is our variable. And so we want to get x by itself on one side of the equation. So how are we going to do that? Well, the way that we do it is we want to get rid of this 252. So with this 252, we've got 252 plus x. So what we want to do is we want to subtract 252 from both sides of our equation here. Okay, and so let's see what we get here. So again, this would be a good one to put in your calculator. 252. So we would find that 108 equals x. And so answer C is the correct answer. But the key thing here is understanding that all of the internal angles in a four-sided plane figure, which would be your squares, your rectangles, your trapezoids, your parallelograms, and the rhombus, I think that's all of them. Yes, that is all of them. And so all of these internal angles are going to add up to 360 degrees. All right, let's go on to the next question now. Question 15 is one of my favorites. So what we're going to do here is match the value of each of the variables to the equation. So let me show you what I mean by this before I turn this over to you. So here are the different values. You've got 40, 18, 1, and 4. And so what I want you to do is look at each equation here, and I want you to find the value of that variable and know that the value of the variable is one of these values over here. So hopefully that makes sense. So go ahead and give this a whirl. Okay, hopefully you had a chance to try this out. So I think that the best way to do this is to just look at each of these equations and to solve for the variable. So let's look at the first one here. Let me highlight it so you see which one I'm talking about. I'm talking about 19 plus b equals 20. So let me rewrite this up here. We've got 19 plus b equals 20. And knowing how to solve these equations for a variable is a fundamental skill for the entire test, really. I mean, you've already seen some examples of doing that throughout this video, but this is a very key example of really all the skills you'll need to know. I mean, it gets a little harder than this, but not that much harder. So what we want to do for all these questions is we want to get the variable by itself on one side of the equation. Our variable is b. A variable is just another fancier word to say something that we don't know. So b is our unknown, aka a variable. So we see that we have this 19 here, right? And so we want to get the b by alone on this side of the equation. So we've got 19 plus b. We don't see a negative or a minus in front of this 19, so we assume that there's like an imaginary positive sign out in front of here, but we don't usually write it. So what we're going to do is we want to do the opposite or the reciprocal operation. So we've got positive 19, so we want to do minus 19, right? So let's minus or subtract 19 from both sides of the equation. 19 minus 19 is 0, so this goes away. And 20 minus 19 equals 1. So we are then left with b equals 1. Okay, so the value of the variable for this first equation is just 1. All right, so I'm just going to cross 1 off here on our chart so we know that we've already covered it. Let me X this out. Okay, so now let's go on to 7x equals 78. Let me write this out here, 7x equals 28. And so what we see here is a case of 7 times x, right? So you can think of there being like an imaginary dot or an imaginary multiplication sign here. So because 7x is really 7 multiplied by x. And so what we want to do is, again, we want to get this x by itself on the left-hand side of the equation. So we want to do the opposite operation. So we have 7 times x. So to get the x by itself, we do the opposite of the multiplication, which would be division. So we're going to divide 7 from this side of the equation, and whatever you do to one side, you always do to the other. So we divide 7 from 28 here. So we see 7 divided by 7, those just cancel out, and we're left with x equals 28 over 7. 28 divided by 7 equals 4. So the answer is x equals 4. All right, so let me plug our 4 in here, and let me cross 4 off on our chart here. And now let's go down to the next one, y equals 20, or y divided by 20 equals 2. So let me copy this down here. We got y divided by 20 equals 2. And so now we've got kind of the opposite case of what we just had, right? We've got a variable y, which again, we want to get the y by itself here. But now y is being divided by 20. So in order to isolate that y on the left-hand side of the equation, we want to do the opposite operation of division. And so the opposite, or the inverse, or the reciprocal, 3 different words for basically the same thing. We want to multiply by 20 here. So we have y divided by 20, and to get rid of that 20, we multiply by 20. And whatever you do to one side, you also do to the other. So on the other side here, we're going to do 2 times 20. All right, and so we've got 20 times y divided by 20. So these are going to cancel out. And the reason that they cancel out is because 20 divided by 20 is going to be 1. And 1 times y is just y. We don't need to write the 1. So we have y equals 2 times 20. And 2 times 20 is 40. So we have y equals 40. All right. And so we can plug this in here as 40. And so now it's pretty obvious now by process of elimination that this is going to be 18. However, let's just go through the math here for practice. So we have a minus 8 equals 10. A minus 8 equals 10. And you guessed it, what we're trying to do here is we want to get the variable by itself on the left-hand side of the equation. A is our variable, which again is another word for something we don't know, which is another word for simply an unknown. So we have a minus 8 equals 10. So we want to get the a by itself, so we want to get rid of this minus 8 here. And so since it's minus 8, we have to do the opposite or the reciprocal operation to subtraction, and that is addition. So we're going to add 8 on this side. Minus 8 plus 8 is going to cancel out. And since we added 8 on one side, we also add 8 on the other side. And so we're going to be left with A equals 10 plus 8, which is 10. Or I'm sorry, 18. So A equals 18. All right, so we've got through problem 15. And hopefully this all makes sense. Definitely make sure if this doesn't make sense that you go back a couple minutes back here and rewatch this section, because this is very, very key. This is a pivotal skill for the GED test. So make sure you understand how I got all of these answers here. All right, let's move on. Let's keep it rolling. Problem 16, the points -3 and 2 are plotted on a number line. What is the distance in units between these 2 points? Okay, go ahead, give this one a crack. All right, let's go over this now. So what we're trying to do is we're trying to find the distance between 2 points, and it says that the numbers are plotted on a number line. So I'm going to draw a number line here. So let me make a big number line here. All right, I'm going to blame this arrow. This is supposed to be a straight line. I'm going to blame that on the pen. You're probably sitting there thinking, nah, it's just my drawing skills. Perhaps, maybe it is. But anyway, so the number line's going to start here at 0, and let's go up to 3 on both sides. So here is 1. And just imagine that these numbers are evenly spaced apart. I'm just approximating this. Okay. So here on our number line, we've got 0, 1, 2, 3, and now we go the other way, right? So we would have -1, and we would have -2, and -3. And I kind of made these lines a little bit farther apart than they, these lines really should be about the same distance apart, but since I've got to write that big negative sign, they're not. But anyway, so it's not perfect, but we've got our number line here, and hope this is going to be good enough to get the point across here. So we want to go from -3 till 2, and so let's see how many units we've got here. So let's just pretend that we are going to go for a walk on the number line. All right. So here's you, or just an imaginary stick figure. You're probably much better looking than this. So anyway, we're going to start at -3 and we'll go to a walk towards the 2. All right, so here is our end goal right here. We're going to hit this 2. All right, and so let me circle it so we know where we're headed here. All right, let's set off on our journey. So we go from -3 to -2, then from -2 to -1, then from 0, or then from -1 to 0, then from 0 to 1, then from 1 to 2. So how many different, so think of think of these as like, maybe you're crossing, let's say that you're crossing a river, right? And these numbers are stepping stones, right? And you don't want to get in the water, so you want to jump on the stepping stones, all right, until you get to 2. 2 is like the other side. So here's what you're going to do. You're going to take a giant leap from -3 to -2, a leap from -2 to -1, a leap from -1 to 0, a leap from 0 to 1, and a leap from 1 to 2. So how many leaps would you have taken? Well, we've got here 1, 2, 3, 4, 5. So the answer is 5 here, right? Let's count that again. So from -3 to -2, that's 1. From -2 to -1 is 1, or that's 2. Then from -1 to 0, that's 3. From 0 to 1, that's 4. And from 1 to 2, that gets us to 5. All right, and so that's the answer. The correct answer here is A. So hopefully this helps it stick in your brain. But that's how I would do it. Just think about it here on a number line, and life's going to be good. All right, let's get at it with 17. A carpenter uses a scale drawing of a house to aid his construction. If he uses a scale of 1 inch equals 4 feet, what is the length in inches of a line on the scale drawing that represents 6 feet as an actual length? So go ahead, just go ahead, pause this video, and give this one a try, and we'll go through it then. Okay, hopefully you had a chance to work on this. So first of all, as always, before we even start this, let's make sure we know what the heck we're trying to find here. So trying to find what is the length in inches of a line on the scale drawing that represents 6 feet as an actual length. So this is important here since this is a fill-in-the-blank question. It says, what is the length in inches? So let me just write inches right here in the box right now, and then our answer is going to go here, but we need to make sure that at the end we have a calculation that is in inches, okay? So what's going on here? Well, let me draw this out here. So let's say that this guy is making a house, right? He's a carpenter. And so let's say that this is like his little blueprint here. So let me just call this BP. And no, I'm not talking about BP like the oil company. I'm talking about BP like B for blueprint, right? So this is his blueprint or his drawing. And so this is, let's say, his actual house that he is working on building. Okay, so let's say that they've got enough of the house done that they've got a fireplace and we've got some smoke coming out of the chimney. I don't know why I've been drawing my houses with smoke coming out of the chimney. I just think it makes more homey, you know, sit in front of the fire with some nice hot cocoa and just kick back and relax. Maybe you can do that after you finish your GED test. So let's say that this is the house that he's building. All right. And so this is his drawing. This is his blueprint. This is the real house, right? So obviously the blueprint is just a sheet of paper. It's not nearly as big as the real house. So he's got to find a scale to use here so that he knows how big something is on the blueprint and how big it should be in real life. So basically 1 inch on the blueprint is equal to 4 feet in real life. So what he's trying to do here is basically he's looking at, there's a line on his blueprint and he wants to figure out what is the length in inches of the line on the drawing that represents 6 feet in an actual length. All right, so we're told here that we're given 6 feet. So maybe there's some line in the house. Let's say, I don't know, let's say that maybe it's the door. Who cares, you know, a 6-foot door. Let's just pretend here. 6-foot door, or there's some part of the house that is 6 feet. There's some line in the house that's 6 feet, and he wants to know what is this length on the blueprint in inches. So basically, all we have to do here is we have to convert this 6 feet into inches. So the way that you do any kind of conversion is you always need what I call a conversion factor. Well, I don't call it that. That's what it's actually called. And our conversion factor is right here. Our 1 inch equals 4 feet. And so it's really actually easy to convert from inches to feet and vice versa. A lot of people overcomplicate it, which is really sad because it's really rewarding for people once they learn how to do this. So we're going to learn how to do it right now. So the relationship here, conversion factor is just a relationship between inches and feet, okay? And so what we've got here is we know that 1 inch is equal to 4 feet, so we can write it like this, right? 1 inch over 4 feet, all right? Or we could write it the other way, right? Like we could write it like 4 feet over 1 inch. It doesn't really matter. There's 2 different ways that we could write out our conversion factor here. And so we have to start with what we're given here. So we know that we're given this 6-foot line, right? The 6 feet of the line. So we have to start with that here. So we've got 6 feet. And so now what we want to do is we're going to multiply 6 foot by one of our conversion factors such that the feet cancel out and we get our answer in inches. So here's a quick mini question here. Which conversion factor should I pick? 1 inch over 4 feet or 4 feet over 1 inches? Well, since I'm starting with something in feet here, I want the conversion factor that has feet in the denominator. The denominator, again, is the bottom number of our fraction here. So this is the conversion factor that I want to bring into play here. So we have 1 inch over 4 feet. And the reason I set it up this way is because now the feet are going to cancel out here. Because remember, feet divided by feet are going to cancel out. Remember how we've been doing that with all of our questions where, like, if we've had, like, I don't know, 20x equals 100 and we divide 20 from both sides of the equation, right? If I divide 20 on this side, we see that 20 over 20 is going to cancel out, right? We've seen numerous examples of that. So it's the same thing with our units here. So we've got feet here times 1 inch over feet, so the feet are going to cancel out. However, the numbers aren't going to cancel out. So we're essentially left with 6 over 4 inches. But we can do a little bit better than that, right? So 6 divided by 4, let's reduce this down more. So these are both even numbers, so let's just divide 2 out of each of these. So 6 divided by 2 is 3. 4 divided by 2 is 2. So we've got 3 over 2 inches. Or we could express that as a decimal. And if you plug that into your calculator, you would see that that is equal to 1.5, right? So this is actually a type of fraction called an improper fraction. You know it's an improper fraction because it's got the number on top, the numerator, is bigger than the number on the bottom, which is the denominator. So if you wanted to convert this into into a mixed number, what you would do is you would leave the 2 in the denominator, and then you want to think of a number that you can multiply here that is going to give you a number close to 3 but is less than 3. So in this case it would be 1. So 2 times 1, and then you add another 1 on here, and that would get you 3, right? So you'd go 2 times 1 is 2 plus another 1 would get you 3. So then if you wanted to convert that back into your improper fraction, you would have 3 over 2. So that's a mini lesson on fractions. And why does that matter? Well, if we didn't convert this into decimals, 1.5, you could have just converted this 3 over 2 into 1 and 1/2. But it doesn't really matter, any of these. So there's multiple different ways to write your answer. You could have written it as 1 and 1/2. You could have written it as 3 over 2, or you could have written it as 1.5. I'm just going to leave it as 1.5 because I think that's nicest, and our answer is in inches. But hopefully that's a little mini lesson on fractions and decimals, but the main lesson here is how to do these conversions, right? And so in this case, we were given a scale to use, right? So it's not like we're converting inches to feet like outright, but we're using this conversion factor the problem is a matter of scale, really. So usually, like if you wanted to do inches to feet, like let's say that we had 6 feet and you wanted to convert that into inches, period, right? We weren't trying to figure out what the length in inches is of the line on the scale drawing, right, that 6 feet represents. If we just wanted to do that outright, we would usually use 12 inches for 1 foot, and that would be the conversion factor in that case. But in this question, we have to use the scale that they gave us, which is 1 inch equals 4 feet. All right, so as always, if you want me to do more explanation on this, just let me know down below in the comments. I will reply. As with any of these questions here, just if any of my explanations are not clear, I mean, I'm sitting here making this long video for you guys. I really hope that this is helpful for you. But, if any of my explanations don't come through, it's because I get a little crazy after sitting here filming for so long, but I want to make sure to put as much value into this as possible. So if there's anything you want me to expand on at any time in the video on any question, just let me know down below in the comments. All right, let's keep it rolling with question 18. Thanks a lot for sticking with me so far. All right, question 18. Joan gets a haircut that costs $19.99 before tax and tip. She pays 6% tax, then added a 20% tip to her total bill, including her tax. How much did Joan pay in total for her haircut? Round your answer to the nearest cent and write your answer in the box below. All right, you know the drill. Give this one a go. Okay, so whenever you've got a calculation like this to do, if you're ever in doubt, just think about, put yourself in that situation. Just think, if I was in this situation and this was my haircut, how would I figure this out, right? But let's break it down how to do it. So as always, what we want to figure out here is how much Joan paid in total for her haircut. Okay, so now let's break this down fragment by fragment. So we know that the initial cost was $19.99 before tax. So we know that our answer is going to be more than $19.99. So if you try this on your own and you got anything that was less than $19.99 for some reason, that was incorrect. Okay, that's okay if you did. We're still learning here. We'll get through this one, but just right off the bat, that wouldn't make any sense. So we know that we're going to be adding something to $19.99. So she pays 6% tax, then she adds 20% tip to her total bill, right? And that's including tax. So let's not worry about the 20% tip yet. Let's just think about how much did she pay with the haircut plus her sales tax. So how would you figure that out? Well, with 6% sales tax, what you would do is you would take this $19.99 and you would, $19.99, and then you're going to multiply that by 0.06. Okay, so times 0.06, right? Because 6% is equal to 0.06 in a decimal form. Okay, so let's calculate this here. So I'm using my handy calculator. Hopefully you are too. 19.99 times 0.06 is equal to 1. Let's round this up here. We'll go to 1.12. I got 1.1994 on my calculator, but we're going to round this to 1.2. All right, so we get $1.2. My one got really crazy there for some reason. So we've got $1.2 extra is what she paid. Okay, so now we've got to add this to that $19.99, right? So we've just figured out what the sales tax is. So she's got $1.2 in sales tax to pay. So she's got to make sure that she adds that to her $19.99. All right, so $19.99 plus that $1.2 that the government's going to take for taxes. So let's add that up here. All right, $19.99 plus 1.2 for the government, and we're left with $21.19. Okay, So we now know that her total bill was $21.19. So she then adds a 20% tip to her total bill. So now what we want to do is we want to figure out, okay, yeah, we could round this up to 21.2. Let's just do that. 21.20. Okay, so we've got 21.20. Let's just round up in each step just to keep this simple. Okay, so now how much did she pay in total for the haircut? So now what we do is we do 21.2, and we're going to multiply that by 20% for that 20% tip. So 20% is 0.2. All right, so 20% expressed as a decimal is equal to 0.2. So now let's put this in our calculator. 21 plus 2 times 0.2. That equals $4.24. So the tip was $4.24. And so now we've got to take this $4.24 and we're going to add this up here. So we've got 21.2. All right. And we're going to add that to 4.24. Okay. And this is going to equal 21.2 plus 4.24. That equals 25.44. And round your answer to the nearest cent. Yeah, I would say that that's rounded to the nearest cent. What I mean by that, round your answer to the nearest cent, is like, say we had something crazy here, like a bunch of random numbers like out here. If we had got something like that, like I would just want you to round that to 2 decimal places, right? That's what I mean by that. So we're good here with 25.44. All right, hopefully that makes sense. Just make sure you understand this because these kind of tax questions will come up. These bills and calculating money and tax stuff, it's fairly common on the test. So make sure that you understood how I did all these steps here. It's not that complicated. Like I said, just put yourself in a situation. I'm sure you've had a time where you've gone to a hairdresser or a restaurant and you had to pay for the meal, and then, or maybe you were out somewhere else, you had to buy some kind of service, and then you had to put a tax on top of that, and then you also had to pay a tip, and you probably had to figure that out in your head or maybe with a calculator on your phone. So just put yourself in those situations whenever you have a question like this and just think how you would do it. All right, let's move on. So question 19, what's the equation of the line? And you see a graph here, and I clipped off the multiple choice questions so that we could get a good picture of the graph on the line here, on the screen here. But if you download that practice test, you will have multiple choice answers for this question. And so over here are the 2 formulas that you'll need. You have your slope, which is m equals y2 minus y1 over x2 minus x1, and also the formula for the point slope formula to help you find the equation of the line. All right, so go ahead now and pause the video, and you know the drill. Okay, so let's go over how to do this question. So whenever you want to find the equation of a line, there's a few tricks to do it, but I don't have the multiple choice questions here, so your answers here, so you're not going to be able to do it with process of elimination, so we're going to have to just find the equation of the line. So for a linear equation, the equation is going to look like this. So you have y equals mx plus b. Okay, and so b is your y-intercept. The y-intercept is where the graph crosses the y-axis. Now, your y-axis is this axis here that goes up and down. Okay, so we don't have all the numbers written in here, but here's the origin, which is 0, 0. Okay, so the origin is at 0 on the x-axis and 0 on the y-axis. So this would be 1, 2, 3, 4, 5, and etc. up to 10. Likewise, our x-axis, right, the x-axis goes this way. It's horizontal, and the same thing, we could go across here. This would be 1, this would be 2, here would be 3, 4, 5, right? And then if we'd go the other direction, starting at 0, we would go, this would be -1, -2, -3, -4, -5, etc., etc. Okay, so anyway, this is the standard form of a linear equation. Y equals mx plus b, and b is the y-intercept that tells you where the graph crosses the x-axis. So we can see here that if you count up 1, 2, 3, or I'm sorry, where it crosses the y-axis, 1, 2, 3. You see here that the y-axis, the y-intercept is going to be 3. So that doesn't really tell us a whole lot yet, but I just wanted to throw that out there. So we already know that the y-intercept is going to be 3. But anyway, let's pretend that we didn't know that. So how would we figure this out here? So first, we want to start by calculating the slope. So the slope, it just gives us a measurement of the steepness of the line, basically. So what you want to do is you want to pick any 2 points on the line. Try to pick points that are close together, but it doesn't matter that much. But just pick 2 points on the line, and then you're gonna put those into the formula here. So maybe let me pick this point right here. So let's label this the coordinates here. And whenever you label the coordinates, you always put the x first, okay? So we would start at 0 and we'd go over 1, 2, right? And so we see that this dot right here is going to be -2, right? The x coordinate is -2. So let me label that as x1. So x1 equals -2. Now the y coordinate, so let's look at our y-axis here, and we see that we go over from the dot until it touches the y-axis. Okay, it hits the y-axis at 5, so let's put a 5 in here, and so we'd say that y1 is 5. Now let's pick another dot here. Let's just pick this one right here, right? And so this is pretty simple because the x coordinate is going to be 0. So x2, we'll call this, is 0, right? So if you start at the x and you go to the dot and go down until it touches the x coordinate, until it touches the x-axis, and you see that it touches the x-axis at 0. So the x-coordinate for this coordinate pair is going to be 0. So the y-coordinate is, well, the dot is right on the 3, because if we count up 1, 2, 3. So the y value here is going to be 3. And so we have, this is our y2. So we now have our coordinate pair, so now we're just going to take our slope equation and substitute this in, right? So we put, where it says y2, we know that that's 3, so we put 3 in for y2 and 5 in for y1 and etc., etc. So it should look like this, right? So you would have 3 minus 5 divided by 0 minus -2. And so we can just put 0 plus 2, right, because it's minus a negative. And so now what we have is 3 minus 5 is going to be, that's equal to -2. And then we have 0 plus 2 is just 2. And so it's going to be -1, right, as our answer here for our slope. So what we now figured out is that the slope is equal to -1. All right, so we know that the slope is equal to -1. So this part of our equation up here, right, we're going to plug in -1. Now we don't know what this x is yet, so that's what we've got to find out. All right, so what we do is we just plug things into this formula right here. The y minus y1 equals m times x minus x1. Okay, so our y1 is 5, right? Remember that from before? We set that equal to our slope, which we just figured out as -1. Okay, and the slope is times x minus x1, which our x1 is -2. So again, we've got -2. We can just make that plus. Right, so now what we do is, let's remember our, please excuse my dear Aunt Sally rules. We want to start with what's in the parentheses. And so we're going to distribute this -1 here. Okay, so what we would do is we would have y minus 5 equals -x. Because we're going to do -1 times x, which gives us -x. The -1 times +2 would be -2. And so then we're just going to add this 5 over here, right? So we want to get the y by itself on both sides here. So what we would do is we would add a 5 onto both sides of the equation here. And now we can rewrite this, and we see that we get y equals -x. Because you don't need to write -1x, so we just put -x plus 3, because -2 plus 5 gives us plus 3. Okay, and so this is our equation of the line here. It's y equals -x plus 3. And as we can see from the graph here, remember I said earlier, you can tell that the graph cross is the y-axis at 3. So we already knew that the y-intercept was going to be 3. All right, but here is the equation of the line. So really, it's all you have to do here is start by getting the slope, and you do that. You just pick 2 points on the graph, get those coordinates right, and then you just plug the coordinates into the formula here, get the slope. Then you just use this formula here: the y equals y1, y minus y1 equals m times x minus x1. Plug the numbers in, do a little bit of basic algebra, and you'll pop out your equation of the line. So hopefully this makes sense, guys. Let's keep going here. We're almost done. Okay, number 20, solve the following system of equations. Go ahead, pause the video, and try this out. Okay, so there's a couple different ways to approach this problem, but the first step that I want to do is always look and see if you can simplify anything. So in this case, what we can do is, let's label these. So let's call this first equation here equation 1, and we'll call the second equation 2. So what we can do for equation 2 is we can divide a 2 out of each term, right? So we can divide each term by 2, and if we do that, we would then rewrite this as negative 3x, let me move this over here, as negative 3x equals y plus 4. All right, and so then up here we've got we still have negative 3x plus 2y equals negative 1. And so what I want us to do is let's get the variables on the same side of the equation. So in order to do that, I want to take this, let's take this y here and let's move it over to the left-hand side of the equation. So we do that by subtracting y from both sides of the equation. So we would then have negative 3x minus y equals 4. And like I said, there's multiple ways to approach this, but I like to get the variables on the same side of the equation. And so let me copy down equation 1 up here. So we've got negative 3x plus 2y equals negative 1. And so now all we have to do is we've got to find a way to add up the two equations so that we're going to be able to cancel out one of the variables. So one thing that you could do is, we know that negative 3 plus 3 is going to give us 0, so what we could do is we can multiply everything in the bottom equation here. Every number here in the bottom equation, or equation 2, we can multiply by negative 1. We could do the same for the top, so let's do it to the top. So let's multiply everything by, in the top number here, let's multiply everything here, we're going to multiply by negative 1. So then we would rewrite this. So what's negative 1 times negative 3? Well, of course, it's 3, so we have 3x minus 2y equals positive 1. And so then our equation 2 stays down here, right? So equation 2, I'm just going to recopy that down here. It's exactly the same. And so now what we see here is that 3x plus negative 3x, well, these are going to cancel out of our equation. So we're now down to just one variable. So now we have negative 2y plus negative y. That's going to give us negative 3y, which equals 5. And to solve for y, we're just going to divide both sides of the equation by 3. Or in this case, negative 3. And so the answer, since these 3's will cancel out, is that y equals 5 over negative 3. And so now that we know what y is, we just simply go back into either equation 1 or equation 2, and we're going to plug 5 over negative 3 into the equation for y. Alright, so let's just go right back here into equation 1, and we'll substitute this in for y. So we'd have negative 3x plus 2 times negative 5 over 3 equals negative 1. Okay, and so now we want to first, let's deal with this multiplication first. So what's 2 times negative 5? Well, 2 times negative 5 is negative 10. So we have negative 3x minus 10 over 3 equals negative 1. Okay, so let's get this variable by itself on one side of the equation. So we'll add 10 over 3 onto the other side. So we'd have negative 3x equals negative 1 plus 10 over 3. Okay, and so now we have to get a common denominator here. And so hopefully you understand how to do common denominators and operations with fractions. If not, look for the other video on my channel. But basically what we want to do here is multiply the top and the bottom number by 3. So we'll do that, and let me just pull this whole thing up here to the top. So we have negative 3x equals negative, now we have negative 3 plus 10 all over 3. And so now, of course, we're going to divide by 3 on both sides of the equation over here. So we would then, let me simplify this out first. And so the way that we're going to do this, basically, it's pretty obvious here. Negative 3 plus 10 is 7, so that's why we've got the 7 over 3. Then we want to cancel out those negative 3s, so that's why I'm crossing those out. Negative 3 divided by negative 3. Whatever you do to one side, you do to the other, so we do 7 over 3, and we're going to multiply by 1 over negative 3, right? Because that's just the same as dividing by 3, and so then we're going to end up with negative 7 over 9. And so that's our answer. X equals negative 7 over 9. Okay, question 21. Which of the following represents a function? You know the drill. Go ahead, give this a try. All right, let's go over it. So this is probably going to be hit or miss for a lot of people based off of whether or not you understand functions. So we'll go over this right now. I'll teach you what you need to know. So basically, the main rule you have to know for functions is that for a function, for each input, there's exactly one output. So let that sink in. Definitely add this to your notes. For a function, for each input, there's exactly one output. So what is a function? Well, a function is a process that relates to each element of a set X, a single element of a set Y. And you might be thinking, what am I talking about? So let's use an example here. So first of all, the function notation. So the function, if we call it f, which it usually will be, it's going to be written like this. It's going to be written like y equals f of x, or function of x. Okay, so x is your input. Okay, and so y is your output. All right, and this is very, very, very important to understand, so make sure that you get this in your notes. For a function, okay, y is your output and x is your input. So I want you to imagine for a second, let's say that there's a store, okay, and at this store, right, for $1, okay, you can get, okay, so for $1, you can get a pack of gum, right? But for $2, you can get, let's say you get a soda. I don't know why I put the dollar sign here. Let me cross that out. So for $1, you get gum. For $2, you get soda. And for $3, let's say maybe you get, let's say you get a coffee. I mean, that's a little expensive for a coffee, but let's say this is like an expensive store. So you pay, just for pretend. So the idea here is that for each input, you get a unique output here, right? So let's say you put $1 in, you give the store person $1. You get out a pack of gum. Your output's gum. You put in $2, you get out a soda. You put in $3, you get coffee. Okay? And so the point is here, though, is that let's say you could never have this, right? You could never have $3 get you a coffee and then $3 also gets you hot chocolate, right? Now, in a real-life store, of course, that could happen. Hot chocolate, which would sound good about now. Now, in a store, like in real life, obviously this could happen, but for the fictional example here, we could never see this, right? Because that would mean that there'd be two inputs that are giving you different outputs. So this can't represent a function. So this would not represent a function, right? The relationship between your inputs and outputs here would not be a function if the coffee was $3 and also $3 would get you a hot chocolate. So let me clear some room out here. So the point here is that for a function, right, for each input that you put in, you can only get one output. All right, so let's go through A, B, C, and D here, and X's, again, are our inputs, and Y are the output. Okay, so what we see in A is we see that if we put 2 in, right, the output's -6, but if we put 2 in, we could also get 7 as an output. That doesn't make any sense. So this is not a function, because for a function, each input gives you exactly one output. All right, so B is extremely wrong, because look, for 2, you have 2 that corresponds to 0, and you also have 2 that corresponds to 3. Doesn't make any sense. This is not a function. 4 can't correspond to -7 and 7, right? Because for each input, there would have to be exactly one output. So we don't see that in B, so B is not a function. Same with C, right? Look, you got 4, and you got an input of 4, output 2, input 4, output 14. You can't have that, right? Because for each input, there's exactly one output. Now, let's look at D here, right? So we see -2, -3, 9, and 4. So we don't see multiple inputs going to more than one output, right? So for each input here, we see that there is exactly one output. It's okay to have two of the same output, right? So 2 outputs can correspond to 2 different inputs. That's not the problem. The problem is that you've got to have for each input exactly one output. So, all right, that solves this. D is the correct answer. Okay, so finally at 22. So go ahead and try this problem out. Alright, hopefully you paused the video and tried this out. We're almost done here. So the strategy here is going to be to take the denominator of the first fraction, which is x, and we're going to need to ultimately get a common denominator. So what we're going to do is we're going to then look at the second fraction. We're going to multiply the denominator of the fraction and the numerator of the fraction, which is the top number, by x. Okay, and so now what we're going to do is we're going to look at fraction number 2. and see that the denominator is x plus 4. So now we're going to go back to fraction number 1, and we're going to multiply the denominator and the numerator by x plus 4. Okay, so I'm probably going to have to rewrite that. So we've got 2 over x, and we're going to multiply by x plus 4 down here, and also by x plus 4 up top. Okay. And so in doing this, right, we're now going to have a common denominator. So this is pretty simple, right? Over here we've got x times x, which is x squared. Okay, so we've now got this. And really this whole thing is now over the same denominator because both denominators are going to be the same now. So we just write this all over x plus 4x. And so now we just have to simplify the top up here. So let's distribute this 2. So 2 times 4 is 8, and 2 times x is 2x. And I'm going to rewrite it with the quadratic, with the x squared first. So this is in the form of a quadratic equation. So we would have 2x squared plus 2x plus 8 all over x plus 4 times x. And that's actually going to be our answer here. Okay, so this is what would go in the box here. And if you wanted to, I suppose you could distribute this x here and distribute the x there. But you know what, since we made it this far, we're just going to count this as the answer. So hopefully this makes sense to you. If this is a weak point for you, definitely go check out my video on how to make fractions a lot easier. And I have a video of that on my channel. You just have to look at my math playlist, my math lesson playlist, and that'll be in there. All right, so let's move on to the final question. Okay, we're finally at the last question here, number 23. So you know the drill. An electronics store sells packs of batteries that include 8, 16, or 32 batteries. If James orders X packs with 8 batteries, Y packs of 16 batteries, and 7 packs of 32 batteries, which expression represents the total number of batters James is buying? And this should say batteries instead of batters. But, you know, I'm going a little bit you know what, crazy, because we're up to 23. You probably are too, but if you made it this far in the video, thank you so much, and I hope this was helpful for you. So let's go out here with a bang, and I will fix this typo. This will not be in the downloadable version, but anyway. So what's going on here is he wants to get, you can think of all these variables, x, y, and z, as you could put any number in there, right? But we don't know how many, we don't know how many packs of 8 batteries he's getting, right? So that's why we would write 8x, okay, and then he's going to get y packs of 16 batteries, but we don't know how many packs, right, so that's why we have y, and you would add that to z packs of 32 batteries, right, so 32z, and so this is because, you know, these are the packs of 8 batteries, so each pack of, you know, see these are 8 packs of batteries, right? So we don't know how many 8 packs he's getting. However, so let's say that he was getting like 2 8 packs. So 8 times 2 would be 16. So that would be 16 batteries here, right? And so, for example, but we don't know how many 8 packs, so that's why we leave it as a variable. Same with 16 and same with 32. So hopefully this one was pretty easy for you. Hopefully you see that this is C. And so that's going to be it, guys. So thank you so much, and I really wish you guys all good luck on your tests. And as always, if there's anything in this video that you want me to expand on, just let me know down below in the comment section, and I'd be more than happy to try to answer your question if there's anything that was unclear, or if there's anything that you had trouble with. I might even make you another video that's separate that breaks something down or gives you more examples if you want. So just let me know down below, and please, please, please subscribe to my channel. Give me a thumbs up. If you found this helpful, I really, really appreciate it. Best of luck on your test. Like I said, you can download that free test. You get everything here for free, and you get a PDF of it. You can print it out, and you can download that right on my website. Links down below, guys. And just, I really wish you the best of luck. Thank you so much, and congratulate yourself. Give yourself a round of applause for making it this far. I'm sure by now you're well on your way. Hopefully this video was worth your while. So again, I can't say it enough. Thank you, and good luck to you. This is Parker from Test Prep Champions. Let me know how your test goes.